This is my second sustainability talk for Module 1. In this lecture, I'm going to talk about water budget and sustainability, and the application will be the search for more water for Las Vegas to support its growth. So we will look in detail at the water budget for the American Southwest and the role of hydrogeology in evaluating that water budget. Unanswered questions out of all of this will be how growth will be accommodated in the Southwest, since the demand will outstrip the available water. And the other major unknown will be what alternate water resources are going to be found. Despite being in a desert, Las Vegas came into being as a location where there was abundant groundwater in very shallow aquifers. As you can see in these pictures, in the early days, water flowed out of the ground from artesian wells. So the Las Vegas water supply was originally desert springs and artesian wells. In fact, groundwater was the primary source of water before 1971. However, as groundwater pumping increased in the 60s, they encountered serious problems of subsidence of the land. Beginning in the 1970s, they began using a substantial amount of water from the Colorado River. There is a problem that the Colorado River water is oversubscribed. They began artificially recharging the aquifer beneath Las Vegas by treating the Colorado River water through the sewage treatment plants and pumping it back under Las Vegas. The long-term plans include tapping into additional groundwater sources, and this was all accelerated by droughts that persisted through the 90s and into the 2000s. So here's a graph showing the time evolution of water usage in Las Vegas. You can see in the earliest days, the dark green represents spring flow, and it was a very small amount that has tapered off as the springs have dried up. Groundwater pumping in the yellow began in around 1910 and accelerated in the 50s and 60s until leveling off in the 70s. Then you can see the use of Colorado River water has been exponential in its growth from the 50s through the present, and at the present time most of the water is coming from the Colorado River. This is from the documents of the Southern Nevada Water Authority suggesting the future direction of water usage, and in this you notice that it goes from the time period 2010 out to 2060, so a 50-year plan. They show Colorado River providing an equal amount of water, just short of 600,000 acre-feet a year in all years from now until 2060. In the dashed black line, you see a projection of water usage based on the trends of water usage in the last few decades, and you notice that dashed line quickly goes beyond the capabilities of the Colorado River. In fact, the crossover point has occurred in just the last few years. That dashed black line represents a projection with no change in water usage patterns. The red line represents their idea of how conservation will decrease the rate of growth of water usage, and that means enforcing water restrictions for watering of lawns and use of lower water usage fixtures for toilets and showers. But the red line still goes well above the availability of water from the Colorado River. The majority of the gap between Colorado River water and the red line is proposed to be filled with the use of in-state groundwater. Now here's an example of what happens when you pump too much groundwater out of a shallow aquifer. The subsidence in North Las Vegas led to whole neighborhoods being condemned as foundations, streets, and sidewalks all cracked and settled. Their use of Colorado River water is also problematic in that over the last decade, from 2000 to the present, the level of water in Lake Mead has gone down, down, down. You see the top of the spillway at 1,225 feet, and at 1,075 feet, they would declare a shortage. In fact, the intakes for water to Las Vegas are located just below that shortage line. And a trend analysis of this data would suggest that they are very close to reaching shortage points. However, in the summer of 2011, water did rise a bit in Lake Mead because of an unusually heavy snow year. So continued use of Colorado water is somewhat problematic. So in order to find alternate sources, the city of Las Vegas looked north, and here highlighted in green are a set of valleys in Las Vegas: Spring Valley, Snake Valley, Dry Lake Valley, Cave Valley, and Del Mar Valley. All of these are enclosed basins with no rivers leaving the area. In 1989, Las Vegas applied for the right to withdraw water from those valleys. In 1991, Las Vegas formed a political entity known as the Southern Nevada Water Authority, SNWA. In 2007, USGS released a groundwater study encompassing a study of those valleys in northern Utah or northern Nevada. In 2007, SNWA obtained the water rights to Spring Valley, the large valley in the north. In 2008, they obtained water rights to additional valleys. And in 2009, Snake Valley, which lies on the boundary with Utah, an agreement was reached to split the water between Nevada and Utah. They began in 2010 to develop the environmental impact statements and to start engineering studies to build pipelines from those valleys to Las Vegas. The plan is by 2014 to have water flowing to Las Vegas. In the Southern Nevada Water Authority documents, they have a table evaluating their legal rights to withdraw water, and you'll see that in Spring Valley they have the right to take out 60,000 acre-feet a year, and they plan to obtain the agricultural groundwater rights for an additional 8,000. In Snake Valley, they have applications in for 50,000 acre-feet a year. Adding all the sources of existing rights and applications, Southern Nevada Water Authority believes they have the ability to pump as much as 170,000 acre-feet a year of water from these valleys. Now the question is there 170,000 acre-feet a year available in these valleys? Is 170,000 acre-feet a year, is that a large number compared to the resource, or is it a small number compared to the resource? So the bottom line is the proposed water usage, some 170,000 acre-feet a year, a sustainable use of groundwater? Here's some promotional material from the Southern Nevada Water Authority, and in that they claim that they're committed to ensuring the development of resources without impacting the rural lifestyle or the environment. They plan on extensive outreach to address questions and concerns about groundwater development, and they plan to have extensive monitoring to protect sensitive resources. Now, people have begun to organize. There's the Great Basin Water Network, which has already organized protest marches and has a whole set of web pages and news and action items. Into this comes the United States Geologic Survey. They were directed by Congress to evaluate groundwater in northern Nevada. They were to find the extent, thickness, and hydrologic properties of aquifers, the volumes, quality of water stored in these aquifers, the subsurface geologic structures controlling the flow of groundwater, groundwater flow directions and gradients, and finally the distribution and rates of recharge of groundwater. Now you'll notice recharge, discharge, and storage are the elements of the hydrologic equation. So here's the front page of the U.S. Geological Survey report issued in 2007. It was a 3-year effort. It should provide the science basis for decision making in Nevada, the science basis for evaluating what is a sustainable use of the water. So what does the USGS have to say? Well, they evaluated the recharge, and the recharge comes from precipitation, so they measured precipitation throughout northern Nevada. Groundwater discharge, well, there is no outgoing flow of water in rivers or streams. All discharge occurs as evaporation, transpiration within the enclosed basins. So they had to investigate the mean annual evapotranspiration, and they had to look and see what water usage there was in the current situation. Finally, they needed to look at how much storage of water there was beneath the surface in these areas. Finally, they also needed to find out whether groundwater flowed out of these regions underground, and they needed to do a very careful accounting to see whether water left in substantial amounts other than by evaporation and transpiration. So here's the picture of the geology of the area. You have ridges and valleys. The ridges stick up and block the flow of moisture from the oceans. Most of the rainfall and snowfall occurs over the ridges. Water infiltrates in the mountain ranges and then flows as groundwater down into the valleys, where it accumulates in large alluvial fills in the valleys. So the valleys have large alluvial fills that make good groundwater reservoirs. So what does the precipitation look like? Well, no surprise, Nevada is very dry. The reds represent little or no rain. The blues represent where rainfall is significant. And as you can see, there are north-south mountain ranges that collect most of the water, which then flows down into the valleys. So recharge occurs in the mountains. Here's a picture of a mountain range with snow cover in the winter and the dry valley in the foreground where the water flows into the subsurface aquifers. So surprisingly enough, despite the extreme dryness of the valleys, the water flowing in the subsurface emerges in springs in the valleys and supports a surprisingly lush ecosystem, as you can see in all these pictures of with green grass and flowing water. So here's an example of the monitoring station the USGS established to look at patterns of temperature and evapotranspiration. There's an example of the irrigated farming occurring in these valleys, where groundwater is being pumped and then distributed over the surface to support the crops. Now there's ample experience in these valleys that even modest groundwater removal lowers the water table and changes the environment at the surface. And these pictures represent areas that did support either farms or pasture land, and following pumping of groundwater, the water table dropped to a point where they could no longer pump it, or the plants could no longer reach their roots down into a saturated zone, result of which was desiccation. Now let's look at recharge estimates from the USGS report. This is a table that contains many numbers, including older estimates of recharge as well as the current estimates, and it includes a number of the valleys. Let's focus on the valleys that the Southern Nevada Water Authority wishes to take water. So Snake Valley and Spring Valley are highlighted. If you come across the table to the far right, the current study shows a 111 acre-feet a year of recharge in Snake Valley and 93,000 acre-feet of water in Spring Valley. So what about discharge? Groundwater discharge, mostly in the form of springs and seeps, transpiration. Phreatophatic vegetation is the desert vegetation that can stick its roots down a long way in order to tap into water. So we have transpiration by that very deep-rooted vegetation, and we have evaporation from soils and open water, and whatever subsurface outflow takes water out of a valley and into neighboring regions. They found in their careful study that about 17% of the water leaves the area by subsurface flow. Okay, their discharge estimate now, focusing on Snake Valley and Spring Valley. You can see the Snake Valley, they estimate 132,000 acre-feet a year of discharge, and Spring Valley 76,000 acre-feet a year. Okay, a table showing these recharge and discharge. The mean annual recharge is green, the mean annual discharge is in blue, the irrigated water use is in the light green. The light green plus the blue adds up to the green in the case of Snake Valley. In the case of Spring Valley, the two that we're going to look at. Now, let's superimpose on these current situations of recharge and discharge the additional discharge associated with the groundwater pumping according to the plans of the Southern Nevada Water Authority. So this is what they are authorized to draw out of each of those valleys. You can see that it is a substantial amount of discharge on top of the current discharge. So what they plan to pump is not a small number compared to what is available. It is not the entire amount available, but it is a substantial fraction of the water that is currently discharged. Here's the USGS estimate of the storage in these very large alluvial fan aquifers beneath the valleys. And for Snake Valley and Spring Valley, you can see that their number of acre-feet is measured in millions of acre-feet a year of total storage. Well, if they change nothing other than to pull the water out of storage, there is enough water in these valleys to supply Las Vegas for on the order of 100 years. However, you realize that as you pump that water out, the water table goes down. As the water table goes down, it changes the local environment. That was the discovery in Owens Valley in California when Los Angeles took the water from Owens Valley. So, the water that's now available for evapotranspiration, supplying springs, plants, and wildlife in these valleys, and supplying the local usage for irrigation, cannot remain unaffected if Las Vegas begins massive groundwater pumping. The only way to accommodate the amount of water Las Vegas needs would be through changes in storage in these valleys. The water budgets in Snake and Spring Valleys has to be altered to support this very large amount of pumping. So are there any alternatives to groundwater? Well, the Las Vegas Water Authority has looked at the alternatives, and here is pumping and desalination from the Pacific Ocean. Pipelines are long, the infrastructure needed to carry the water all the way to Las Vegas is substantial. They've done a back-of-the-envelope calculation of the costs, and so for a site off of the California coast, the total capital costs to build a supply capable of supplying 150,000 acre-feet a year would be on the order of $10 billion. associated with that would be an annual energy cost of about $400 million. So they compare that with the amount of the cost of their in-state groundwater, which they figure to be about 47 million a year in operating costs and a capital cost of $3.5 billion. So they believe that the in-state groundwater is about the third of the cost to initiate it, and would have operating cost that's probably on the order of a third per year. So it appears that groundwater mining will continue into the foreseeable future. At this juncture, there's no indication that Las Vegas will begin pumping water from the Pacific Ocean, but if they do pump water from the valleys in northern Nevada, there will be short-term and long-term consequences. So no sustainable solution are currently under realistic consideration. So this ends our discussions and lectures for Module 1.